right, we are moving on to talking about compound inequalities. So a compound inequality is just when we have two inequalities joined by the word and or, which will make sense later. So a compound inequality is when two inequalities are joined by either the word and or. And the way that we write them is different. We'll see that in a second. So every state has a law that says something along the lines of a person shall not drive a motor vehicle at such a slow speed as to impede or block the normal and reasonable forward movement of traffic. So essentially, don't drive so slow that you're a nuisance. And in Iowa, in highway driving, the minimum speed is 40 miles per hour, and the maximum speed would be 70 miles per hour. So we're going to look at what the graph would look like, and then how we would write that as an inequality. So if I'm driving at least 40 miles per hour, that includes 40. So I'm going to have a closed dot at 40. And then I can drive at most 70. So I'm going to have an open dot or a closed dot also on 70. I also know that I can drive anywhere in between 40 and 70. So I'm going to shade in between here. I can drive anywhere in between 40 and 70 miles per hour on the highway. So if I were to look at this in terms of like an inequality, I would say that my speed, S, needs to be greater than, I'm going to try to calibrate this quick. It obviously didn't work the first time. We'll try it again. Okay. Let's try this again. So S, my speed, needs to be greater than or equal to 40, but it also needs to be less than or equal to 70. So there's a better way that I can write this. I can write this as 40 is less than or equal to S, my speed, is less than or equal to 70. I've got my minimum of 40 here, my maximum of 70 over here, and I need to drive somewhere in between those two values. Okay, so there are two types of intervals that we're going to be talking about. The first example of an interval is what we call a finite interval. So if something is finite, it has a beginning and an end. We know where it starts and we know where it finishes. It's finite. We call these and statements. And this is how they're set up. It's exactly what we just did with our first example. So I'm going to have my minimum, and then I will have a less than or equal to inequality sign. My variable is in the middle, and then I'll have another less than or equal to sign with my maximum, oops, not my mix, my maximum on my right-hand side. Okay, have my minimum value, less than or equal to, variable, then my maximum value on the right-hand side. All right, and this is how this is going to look. Let's say that I have negative 3. Oops. Negative 3 is less than or equal to x, is less than or equal to 10. Okay? When it includes it, I use a closed dot. So I'm going to have a closed dot at the value of negative 3. I'll have another closed dot at the value of 10. And my value x can be anything in between negative 3 and 10. So I'm going to shade this inside part. Okay? I'm going to use the highlighter, I think, because you can see it better. Shading the in between. This tells me that my value x can be anywhere in between negative 3 and positive 10, including negative 3 and 10. Both of these are closed dots. This is what I call a closed interval. Okay, another example. I may have 11. 11 is Monte-Morris's number. I love Monte-Morris. 11 is less than x. Is less than or equal to, let's go 31 for George Niang. So, I've got 11 is less than x. That's going to be an open dot at 11. And then I've got x then is less than or equal to 31. So I'm going to have a closed dot at 31. And I'm going to shade in between. So I've got this in between. I have one open dot, one closed dot. This is what I call a half open interval. It's half open. All right, a couple more examples here. Let's go the other way around here. So let's say I have this at -2 and let's do this here at +6, and I'm going to say that it's shaded in between. Okay, I've got a closed dot on -2, open dot at +6, so my inequality will look like this. -2 is less than or equal to x is less than 6. Okay, it includes -2, doesn't include 6. I have one open dot, one closed dot. This is my half open interval. All right, last example here. Let's say I have open dot on 1 and another open dot on 7. Shade the middle.
So then, no matter what you put in, so it's like kind of like saying they put in.
All right, I've got 1 and 7. I'm shading in the middle here. Maybe. Goodness. No good. So if I were to write the inequality for this, I have an open circle on 1, an open circle on 7, so I'm going to have 1 is less than x is less than 7. Both of my points have open circles on them. This is called an open interval. All right, all of those are finite intervals that use the word and. Now we're going to look at infinite intervals. These are intervals or inequalities that use the word or. So the way that these are going to be set up is I have my minimum, nope, scratch that. I have x is going to be less than or equal to some minimum, or x is going to be greater than or equal to some maximum. And that'll make sense here when we do our example. Okay, so let's say that I have x is less than -1, or x is greater than or equal to 5. I'm going to have an open dot on -1 because it doesn't include -1. If I were to just graph x is less than -1 on its own, I would know, oh, it's less than, my arrow needs to be pointing to the left. So that's what I'm going to do, is have an arrow pointing to the left. Or x is going to be greater than or equal to 5. So I would have a closed dot here on 5. X is greater than or equal to 5 means that my arrow is going to point in the right-hand direction. Now, can x be anything in the middle here? The answer is no, it cannot. x cannot be anything in between -1 and 5. My solution to this inequality is x is less than -1 or x is greater than or equal to 5. Okay. We're going to write some inequalities and we're going to graph them. A number c is less than 5. Well, I can read that and say, oh, I see that. C is less than 5. I can do that. C is less than 5. And c is greater than or equal to -2. Now, you may be looking at this and you're like, well, I noticed, or you should have noticed, this is an and statement, right? I have the word and. Well, come on. Have and up here, right? This is an and statement, which means that it's going to be one long inequality instead of two separate ones like we did before. But I have a greater than or equal to sign here. And then my format for my and inequalities, my finite inequalities, I only used less than signs, or less than or equal to. But what I have to do is think about, what does this really mean, right? So in these two numbers, what's my minimum? Well, I know that my minimum is -2, right? That's my smallest number. Well, based on this inequality, what is my c's relation to -2? Well, I can look at this and say, well, this says that c is greater than or equal to -2. That is going to be the same as saying that -2 is less than or equal to c, right? Remember, the alligator eats the bigger number, right? So in this case here, I've got c is greater than or equal to -2. The alligator is eating the c because it's a bigger number. Same thing down here. -2 is less than or equal to c, while the alligator is eating the c, it's the bigger number. So I didn't really change anything, I just flipped the order that I'm writing it in. And I have that c is less than 5. So my inequality is going to look like this. -2 is less than or equal to c is less than 5. So then I can go ahead and graph it. I've got a closed dot here on -2. I'm going to have an open dot on 5. We'll just say it's here. And we will shade the middle. And that's it. Okay, my next one, a number t is less than -1 or greater than or equal to 4. So right away, I'm noticing I've got this or that I need to deal with. So that gives me a clue as to what I'm going to be doing. So I'm going to have two separate inequalities instead of one long one. So I've got t is less than -1 or t is greater than or equal to 4. That's my inequality. I'm done. Now I just need to graph it. So it's just less than -1, so I'll have an open dot on -1. T is greater than or equal to 4. 2, 3, 4. So I'll have a closed dot on 4. And then I'll have arrows pointing in opposite directions. One's going to the left, the other one's going to the right. And that's my solution for that inequality. All right, so now we're going to look at solving inequalities. So the way that we solve inequalities is the same thing that we've been doing up until this point. It's just going to look a little bit different because instead of having like x plus 1 equals 5, or even x plus 1 is less than 5, now I have three different terms. I have one on the left, one on the right, and then one in the middle. And so let's say that I was just solving x plus 1 equals 5, okay? I'm kind of just looking right at this last part here, right? So if I was just solving x plus 1 equals 5, well, I know that I need to in order to get x by itself, I need to subtract 1. But whatever I do to one side, I have to do to the other side, and so I would subtract 1, oops. I would subtract 1 from this side as well, right? Well, the same is true when I'm dealing with inequalities. So what I need to do is I know that I need to get x by itself, right? And so in order to do that, I know I have to get rid of this 1. So I will subtract 1. And then I need to subtract 1 from all parts of my inequality. So I'm going to subtract 1 from this first part. I also need to subtract 1 from the second part, and I need to subtract 1 from the left-hand side as well. When I do that, -3 minus 1 is -4, is less than, I just have x left in the middle, right? And then 5 minus 1 is 4. So I've got -4 is less than x is less than 4. So then if I graph this, I've got an open dot on -4, an open dot on +4, and I just shade the middle. Oops. And we're good to go. That is my solution for this inequality. Something to keep in mind is that in this case, the rules for inequalities still apply. So if I look at this next guy, I've got -7 is less than -3 minus 4 is less than or equal to 2. Okay, the first thing that I look at that I know that I need to get rid of is this 4. So to undo subtraction, I need to add. So I will add 4 to every part of my inequality. So -7 plus 4 gives me a -3. -3 is less than -3x is less than or equal to 2 plus 4 is 6. Now, in order to get x by itself, I need to divide all of my terms by -3. Now, this is where I need to remember that if I multiply or divide by a negative number, my inequality sign flips. So, I've got -3 divided by -3 is 1. My less than is going to switch to a greater than. This is just going to leave me with x. And then I've got -6, or 6 divided by -3 is going to give me a -2. So this needs to flip to a greater than or equal to -2. Now, am I done with where I'm at? Your answer should be no, and here's why. When I gave you the formula, or kind of the way that we write and statements and inequalities, you should have noticed that I started with my minimum. I had a less than or equal to sign. Then I had my variable is less than or equal to my maximum. Well, this is backwards. So I need to rewrite this to be the way that I need it to be. So my minimum here is -2. So I know I want that first. X relationship with -2 is that x is greater than or equal to -2, which means that -2 is less than or equal to x, which is less than 1. This inequality says the exact same thing as this one. It's just written in a different way. Okay? They're saying the exact same thing. This is just the format that I need it in. So, -2 is less than or equal to x. So I need a closed dot on -2. X is less than 1, so I need an open dot on 1. And then I need to shade the middle in between. And then I'm done. Okay, our last numerical example then is with an or statement. These should be super straightforward, okay? These are what we're used to solving, right? I have stuff on one side of my inequality sign, and I have other stuff on the other side of my inequality sign, and nothing else to deal with. So my first inequality is 2x plus 6 is less than -2. So my first step is going to be to get rid of the 6. So I'm going to subtract 6 from both sides. Then I've got 2x is less than -8. I'm going to divide both sides by 2 to get x by itself. I'm left with 2 is less than -4. I don't flip my sign in this case because I'm not dividing by a negative number. Even though I get a negative number in the end, I'm still just dividing by a +2. So my sign will stay the same. Do the same thing over here. So I'll add 5 to both sides. I get 4x is greater than 8. Divide both sides by 4. Leaves me with x is greater than 4. So my inequality, oh, x is greater than 2. I was going to say that doesn't look right. 8 divided by 4 is 2. So my inequality is going to look like this. X is less than negative 4, or x is greater than 2. So when I graph this, I'll have an open dot on negative 4 with my arrow pointing in the left, to the left. And then I'll have another open dot on positive 2 with my arrow pointing to the right. And that's all I have to do for that one. This is kind of hard to see, I realized. But all right. Last problem, and this one's been a doozy today. So, a recommended storage temperature for chocolate is 15 degrees Celsius to 20 degrees Celsius. We need to write and solve a compound inequality that represents the possible storage temperatures in degrees Fahrenheit using the formula C Celsius equals 5/9 times F minus 32. Okay, it's a lot of words. We'll break it down. Let's just think of this as, if we were going to think about this in terms of Celsius and not Fahrenheit, what would my inequality look like? Well, I know that this is a finite interval. I have a range where I know the beginning and the end. My beginning is 15, my end is 20. So that means my minimum is 15 and my maximum is 20. So if I'm going to write this as an and statement, I would have 15 is less than or equal to T, my temperature, is less than or equal to 20. Right? This is in degrees Celsius. This is what my inequality will look like. But I'm not dealing with degrees Celsius. I want to know what is its equivalent in Fahrenheit. So this is where we get to do your favorite thing ever. And we're going to solve for x. This is a literal equation. So I've got C equals 5/9 times F minus 32. Now, if you remember, this is where we're going to break the rules a little bit. Normally we would want to distribute here, but instead I'm going to divide both sides by 5/9 because the only thing on this left-hand side of my equation is just my parentheses and then whatever's out front of it. And if you remember, parentheses out front of something just means that we're multiplying. I'm just going to get my eraser. So it's not working. And so I can divide both sides by 5/9 in order to get rid of the fraction on my left-hand side. So I'm going to divide this by 5/9. I'm going to divide C by 5/9. I know that dividing by 5/9 is the same thing as multiplying by 9/5. So I'm going to switch this around and say that I've got 9/5 C.
Jared, hey, please come to the office. Jared, please come to the office.
I've got 9/5 C equals F Fahrenheit minus 32. Now to get my Fahrenheit by itself, I'm going to add 32 to both sides. Oops. Add 32, add 32. So my new equation then is I've got Fahrenheit equals 9/5 Celsius plus 32. Now, all I need to do is plug it in. So, I'm going to use my brackets here to kind of do this. So, I've got 9/5 times 15, and I'm going to take that plus 32, and I know that that needs to be less than or equal to my temperature, which needs to be less than or equal to, same thing over here, 9/5 times 20, times 20 plus 32. Okay, so now I just need to simplify, and this should be pretty straightforward. So I'm going to cross simplify here. 5 goes into 5 once. 5 goes into 15 3 times. 9 times 3 is 27. So in here I've got 27 plus 32. When I add those two things together, I get 59. We're gonna do the same thing over here. 5 goes into 5 once. 5 goes into 24 times. 9 times 4 is 36. Got 36 plus 32. 36 plus 32 is going to give me 68. So, if I'm going to rewrite this inequality, which I should do because this is all messy, it'll look like this. 59 is less than... Alright, we're going to use the eraser. 59 is less than or equal to t. It's less than or equal to 68. This is my final inequality in terms of Fahrenheit. And I am finished with that. We're not going to graph this one. So that is all for 2.5.